Welcome to the 7.3 video. So today we're going to learn, oh, there. We're going to learn all about a whole bunch of different theorems, such as the angle bisector proportionality theorem, the triangle proportionality theorem, the converse of the triangle proportionality theorem, proportional segments theorem, and the triangle mid-segment theorem. If you haven't already written these down in your Chapter 7 toolbox, pause the video and do that. It'll save a lot of time during watching the video. Okay, so the first one states this. You guys can read it for yourself, but let's investigate what it actually means. So if it's an angle bisector, that means that this angle is the same as this angle. I know that AB is 5, AC is 15, BD is 4, and we don't know what this is. This really is the equation. I can solve this by going 5 over 4 equals 15 over x. So I can do this, solving this one of two ways. I can just say, well, I can cross multiply, get 5x equals 60, divide 60 by 5 and get 12. Or I could say, well, 5 times what unknown number gives me 15? Well, it's 3. So then I just multiply 4 by that same number. So x would be 12. So when I'm setting up the equation, I want to write the numbers on the pictures. And then I'll be able to see the equation. This line here, the angle bisector, is my equal sign. And I have it numbers like that. I also could set it up if the picture was drawn like this, where this is angle bisector, this is angle bisector. I could also stack them. So if I had 15 over 3 equals x over 4, I'd have 15 over 3 equals x over 4. Oh, well, 15 over 3 reduces to 5. X over 4. Okay, wait up. This should be a 5. I don't know where 3 came from. This is a 5. So 15 over 5 equals x, that would be a 3. I wondered how I would get 12 there. I have x equal 3 times equals x over 4, multiply, and I get x equals 12. So either way, I make the equation here, the angle bisector, the equal sign, and I stack the equations, and I get a number. So here's another one. I'll do this one, and I'll let you pause the video for 3. So as I said, this is the equal sign. It makes it, I want to solve for dx. So I have 8 over 24 equals x over 30. 8 over 24, I'm going to reduce that just to make my numbers a lot easier to 1 over 3 equals x over 30. Now, if I cross multiply and I get 3x equals 30, divide by 3, x is 10. I also could just think, hey, what would make this the equivalent fraction? And a 10 over 30 would reduce to a 1/3. So you pause the video and you do 3, and when you come back, we'll do it together. Okay, welcome back. So we're solving for AC or CA, that's my unknown. This is my equal sign. I got some fractions here. 9 over unknown equals 11 over 22. I'm going to just think, hey, 11 over 22, that equals 1/2. So that's going to then equal the 9 over x. Well, this is twice as big as the bottom, it's 1/2, so x would be 9 over 18. So x is 18, so that length is 18. Here's another theorem called the triangle proportionality theorem. You guys can read about this and write it down in your toolbox. But what this one states is that if it's these lines are parallel, this triangle here is going to be a dilation of this triangle. So those are going to be the same. So that's why the triangle is similar. What I can do is I can say, well, once again, this is a equal sign there, and these numbers are stacked. So I can say 12 over 9 equals 16 over x. And then I can cross multiply, like I did here, and then divide by 12, and I get x is 12. So that's one way to do it. This, though, it's this length to this length is 12. It's not the full length. This length to this length is 16. So here's another one. This one's a little different because this goes for the whole length. So I will have to subtract this to get 14. So I have 14 over 4 equals, this is the equal sign, I got my equations there. 14 over 4 equals x over 6. I can reduce this to make this 7 over 2. I'm not going to cross multiply. I'm just going to multiply each side by 6 because these will cancel. If I cross multiply it, I'd have a 2x, which is 5 by 2. This 6 and 2 will cancel out to a 3 and a 1. So x here equals 21. So pause the video. You guys do this one. Welcome back. So as I did with the last one, I have to find just this length. This length, if I know the whole thing is 20, this length would be 20 minus x. And then I'm going to have my equation. This can be equals lines. So I have 20 minus x over 4 equals, this isn't 20, this is x, equals x over 12. This one I will want to cross multiply. So I have 20 minus x times 12, and 20 times x, or 20 times 12 is 240. 240 minus 12x equals 4. So 4x cross the multiply this way. I'm going to add 12x to both sides. So I have 240 equals 16x. I'm going to divide by 16, so 240 divided by 16. I get x equals 15. So that's how we do that. The converse, that's basically the same thing, where if I prove that these are proportional, then the lines are parallel. So looking at this, are these going to be parallel? Well, let's find out. This is my equal sign. 2.7 over 7.2 equals, is it equal to? We're going to find out. Let's just put this in the calculator. 2.7 divided by 7.2. The left side is 0.375. And then 4 divided by 9 is 0.444, repeating. So these ones are not parallel because this doesn't equal the left side. The proportion isn't the same. You guys pause the video and try this one. Okay, welcome back. So hopefully you guys set it up where you said, is 3 over 4 the same thing as 24 over 32? Well, this is 0.75. And let's plug this in the calculator. 24 divided by 32. That is 0.75. So these ones, yes, they are parallel. This line and this line I can mark as parallel. Proportional segments theorem. This one's very similar to the previous one, where the only difference is the other one, the one we just learned, had it was 2 parallel lines, and the line went like this. For this one, that line goes here, so it's then this segment. Oh, it's out of the way. this segment and this segment and this segment and this segment. And it would still be the equal sign, and then I'd have the division sign. So this is very similar to the previous one. Okay, we have the triangle mid-segment theorem. The mid-segment of a triangle is parallel to the third side of the triangle and is half the measurement. So mid-segment, let's go over what that is again. That's when this piece and this piece are the same, and this piece and this piece are the same. So let's see what we can do with this. So I know that's the same. The third side of the triangle is half the measure of the third side of the triangle. Oh, so this is 10. That means this is 20. If this is 2x, that means this one is just x. So very simple. I just have to prove that these are, in fact, a mid-segment. Okay, so Miss Zoid asked her students to determine whether Rx is a mid-segment of triangle TUV or Y, given this is 14 and this is 7. Carson told Cecilia by using the triangle mid-segment theorem, he could conclude that RD is a mid-segment. Is Carson correct? Well, this is in fact double the length. So therefore, that portion would have to be true for this side to be equal to this side, and this side equal to this side. So yes, it works. Okay, so that's the end of the instruction. You do is the 3 problems on Talk the Talk on page 492, number 1, and then number 2 and 3, where you're going to be proving things, and you'll be stating what theorem you'll be doing the proving with. We're not given numbers, so you're just naming the theorem. And when you're done, let's do the check-in.